So we finally reached Ampere's law. The first thing we want to do is define it. So we've already written it out, but since we already know different forms of volume, current, density, we might be able to rewrite Ampere's law in different ways. So Ampere's law states that the closed loop integral of the magnetic field will always be proportional to the total current passing through the cross-section enclosed by the loop. So as we already saw, Ampere's law was written like this. The integral of B dotted with dl is equal to mu naught times I enclosed. But from our previous section, we know that there's another way to find the total current. So total current, we know that total current can be rewritten as the surface integral of J dotted with ds. So these are the different ways or formats of Ampere's law. So how do we make sense of this? The first thing we want to do is just try and understand where this equation comes from. So let's first draw a diagram. We'll just say we have a current carrying wire with current going up the wire. And let's say we're trying to solve for the closed loop integral or path integral, similar to work along a path. It doesn't really matter what path you take. As long as it's closed, it'll still equal to the same thing. So we just form some sort of closed path around the current carrying wire. We'll say it's going this way, counterclockwise. And we also have this being ds. And we'll call this C for our curve. So looking at this, we call that curve C an Amperian loop. So this is analogous to a Gaussian surface, and the Amperian loop is the boundary of a region that has current flowing through it. The only requirement for an Amperian loop is that it is a closed path. So in purple on the right, we have a closed path. So how do we know whether the current is positive or negative? First, we take a look at the path C. We note that at any point on this path C, there's going to be a differential path length, dl. And at that point, there could also be some sort of magnetic field. So whatever the magnetic field is, we don't want to worry about that yet. We just care about the curve. So basically the path of the curve dl and ds, which is pointing in the direction of the current. So in order to figure out whether the current is positive or negative, we have to use the right hand thumb rule to determine whether the current is positive or negative. So what exactly is the right hand thumb rule? Let's do a quick sketch. Ugh, I cannot draw. So there's my thumb. It's actually okay. So I have my right hand thumb rule, that's my right hand, and I'm going to have this pointing up towards ds or I, and then I have my fingers curling along dl or along the curve C. So thumb points along ds, fingers curl along dl. What can we determine from this? The convention is that the current along ds is positive when dl is counterclockwise. So this would be positive current as a convention. So we'll be going through several conceptual problems afterwards just to test your knowledge and to make sure you understand how to apply Ampere's law and just to analyze different types of Amperian loops.